How are you? This has been a great conference. So, I don't know what she said, but I think she said I'm very old. And so one of the things I like at any age is learning new things. And this was a great year for WWDC. We got Swift UI, we got Combine, we got the new differentiable collections, and there was so much things to learn. And the thing that I like to do, instead of just giving you code that you're going to copy down, and I want to give you some intuition. So we're going to talk about Combine today, and we're going to talk about some intuition. And let's start with this app I wrote and designed myself. I'm just so proud of this. Thank you. So we've been working with view controllers forever, so let's start in UIKit. Let's start with view controllers, and let's motivate some of this stuff. And so if I have a class that's a view controller, that subclass is UI view controller, which I got to say, after doing Swift UI for 4 months, this looks so odd. And the way we connect to a label is, of course, with an IB outlet. And here's my model. Right? We're going to do MVC. There's my model. I'm so proud of that, too. And when I press the button, it has to do something, and so we're going to use an IB action for that. And so when we press the button, we're going to increase our value by 1. That's how the counter went up. And we're going to change what is displayed there. And, man, I hate code like that. You say, well, it's just MVC. We've been doing that for, I don't know, since Smalltalk. You see, the problem with code like this is, of course, it just makes it too easy for people to understand what we're doing, and then we don't keep our jobs. So let's take our view controller and let's make this a little more complicated and introduce a view model as well. And so if I have a view model, the view controller owns the view model. And you know better than this, we don't want the view model to own the view controller, or I've got this retain cycle that a speaker was talking about before. And so what we've done for many, many years is we introduce a delegate, and then view controller conforms to the delegate protocol. And I'm very proud of this picture because if you look at it, the view model no longer is talking to the view controller. Notice it's now talking just to the protocol. So all it knows is what the protocol has done. This is just the delegate pattern, and the way this works is I have my view controller. My view controller owns the view model. It knows how to increase the value, so it's going to send a message to the view model, say, hey, view model, can you increase the value? And so that's the view controller sending the message to the view model. And now I've got this protocol, the view model delegate, and the view model delegate has some method. And what we've done in Objective-C and now Swift for many years is delegate methods are something will do something, something did do something, something should do something. And so in this case, I have view model did update my int to, and so when I get that, I will update my value. And so here's my view controller talking to my view model. And now the view controller conforms to that protocol. It's got to implement that method. But it also has to tell the view model, I'm your delegate. I'm the one you call back. And so the view model doesn't know anything about me except I do conform to the delegate, so I do implement this method. So the only thing the view model knows about me is it can call this method on me, and this is the method where I display the information. I say, number view, can you display the int? And what we've loved about the delegate protocol for all these years is it gives you the int you want to display. You don't have to go find it somewhere. And so we have that. And the last piece, of course, is our view model. Our view model has this link to the delegate. It is set weekly. And when I tell it to increase value, it says delegate question mark. What's the question mark there for? Don't you love this about Swift? You don't have to say, if it's nil, do this. If it's not nil, you're great. You just optional chain, and you get the right behavior, and we get our delegate pattern, and there it is in Swift. And we're happy, except if you watch the WWDC videos, 8 years ago, Apple said, stop doing this. But then they shipped 4 APIs that did this. So they didn't really mean it. But what they said was, instead of using delegates, use closures. Instead of calling me back and telling me what to do, I'm going to pass the behavior forward. And I'm going to use closures for that. So here I am with my view controller and my view model once again. And I have this closure that I created in my view controller. And the closure knows about what this label is that it's going to set the value with. And the view controller owns the view model, so instead of having this delegate and this callback, careful, very expensive animation here. I know, I'm just so proud of myself. And so that's how we work with closures. The code looks like this instead. The code looks like this. I have my view controller, and you don't have to pay attention to this. You have to pay attention to here's the closure I'm sending forward. It looks almost identical to the callback method. The difference is it is a closure, and so that's the thing that I'm sending forward. And I send it forward by saying, hey, view model, set your updater, and your updater has to be some method. Set your updater to be this guy. And so that's what gets the closure over to the view model, and now the view model just knows what to do. Here I am in the view model. The view model says, I want to increase my value, and so what I'll do is I'll increase the value. So how do I get the closure called so I can update the screen? Well, I've got to set the closure, and if you like nothing else in Swift, the fact that you can define functions and closures this easily, do you remember block syntax? Look at that. Updater is just a function that takes an int and doesn't return anything. And so that's wonderful. I said it when I said viewModel.updater equals my closure. And now, one of my other favorite things in Swift, I'm a big fan of Swift, is this. When the model changes, use didSet to say, call that closure. So anytime the model changes, there's no calling it, it's just wait. And when the model changes, I will display the change. And just lovely. I'm not going back and writing old code ever again. So let's take stock. Here's my flow at runtime. I've got my button. The user taps the button. That fires an action in the view controller. The view controller has sent messages across to the view model, and what it's saying is, hey, can you increase your value? And the view model says, I will. I will get the model to increase its value, and now this is this one direction state change. And we had a lot of talk at WWDC saying that was something big in Swift UI, that was something big in Combine. We've been doing this for years. There's no reason we had to wait for Swift UI to do this. We can do this with UI view controllers and UI views. And so it's a one-direction user action to state change. And so now that the model is increased by 1, the view model says, hey, the model has changed, and it sends the new information into the closure, and the closure says, oh, I am holding on to this label, and I'll display the new int in the label. And that's what we do with closures. Now, just as Hello World has been the law for years, now if I give a talk, I think the law is I have to talk about Swift UI and Combine. So let's look at Swift UI and Combine, and we don't have view controllers in Swift UI. Oh, we won't worry about that. If you imagine we have view controllers and we have view models, then what changes here is the view model says, look, I've changed. You can take me back, I'm a new man. And so here I am in my view model, and in my view model, I have this value. This is my model. It's privately settable. It is mutable. It is an int, and I start out with it being 0, and I will increase that value by incrementing it by 1 when I need to. Now, I said we don't have view controllers. What we have in Swift UI is something called the content view. And the content view, we're going to set up with all the pieces that we want. It's going to have that view model, because I have to hold on to the view model where all the changes are happening. And it has something that looks like this. Daniel, there's a lot of spaces in your slide. We're going to fill it in, but I want those of you that haven't done any Swift UI not to panic, because you can look and say, essentially what I have is a vertical stack that contains a text and a button. And the text is going to display some string, and the button is going to say increase on it, and it's going to have some action. So you can picture I've got a label and a button just as before. My text is going to say whatever the view model's value is, so that's what went from 0 to 1 to 2, and the button's action says, view model, can you increase? And that's what incremented it. Now, the view model is changing, but I don't have a did set here anymore. The view model is a class. And so in order to find out when a class has changed, we label it as an observed object. And an observed object just says, I want to know when you've changed. And not just when you've changed, but the thing that you're holding on to. So you're a class, you probably haven't changed much, but the thing you're holding on to has changed. So I want you to tell me that. And so it's content view in the view model, but I have it as view controller so as not to panic you. Here's my view model, and the content view is got the observed object, so the view model is the thing that I am observing, and so it is called an observable object. Is this going okay? You'll tell me if it's not, right? And I guess say, well, it's observable, but what is it that changes that you want to tell me about? And it is this value, and I mark that as published. And this is actually combined inside of Swift UI. And when, I don't know if you saw any of the early videos or you played with the early betas, it used to be horrible. They've made it into this, and this is so much nicer. But you used to have to conform to this pass-through subject, and you have to use generics and all these things, and then you had to use the did set, and then it was the will set. Now it's just this, mark it as published, and it'll tell you, I've changed. I mean it this time. And so when it changes, the text updates its value, which is a huge lie. The text doesn't update its value. The text says, I'm no longer valid anymore. It goes away, and Swift creates a new text with the new value. Swift is throwing things out all the time. So if you stare hard enough, you might see the code that's coming. But before that, we have a demo. That's it being published. Whenever I hit the button, it eventually goes across the screen. I've spared no expense. And so that's it being published. And that's when it tells you that the value has updated. And you say, okay, Daniel, but I'm not ready for Swift UI. Well, how about target action? You've done target action forever in UIKit. So let's look at target action here. And I'm going to click my next button. And it's going to pick a random number between 0 and 2. Very impressive. So here's what it looks like. It is, inside of UIKit, it is not Swift UI. I've got my view controller. I've got my IB outlet to the label. I've got my action that gets called when the button gets pressed, and I'm going to call random, and I'm going to pick a random number between. Don't you love the new syntax for random? It's random in 0.2. I know, you liked arc for random and then modding it out by the... So that's how I do a random number, and I'm going to display it, and I can't just begin to tell you how much I hate that code, and we may fix it before we're done. So let's look at combine in this setting. I've got my view controller, I've got my label, I've got my random, I've got my model. Ready? I love this action so much more. This action doesn't tell the label what to display. This action says, change the model value. Give me a new number between 0 and 2. Isn't that nicer? The button doesn't need to know about the label. The view controller doesn't need to know about all these things. You end up with these 1,000-line view controllers. All the button is doing is picking another number between 0 and 2. And you say, well, okay, smart guy, how do I see it on the screen? Well, let's get there. When I get a new value, I need to publish it. And if I have something publishing it, I need someone subscribing to it. If no one is subscribing to it, it's not going to show up anywhere. So the way Combine works is I've got publishers and subscribers, and if you're publishing values and no one is subscribing to it, why should you tell anybody? That's a waste of your time. As soon as someone's listening, now you say, okay, I'll tell you. So we have a subscriber, and now let's connect the subscriber in ViewDidLoad. And so my value subscriber is to be connected to $value. Perhaps to localize your code, it should be $value. $value is a detail in SwiftUI that says you're binding to something. And so as it changes, you're getting the changes. And so you're not binding to value, you're binding to this wrapper around value. And so I've got my value subscriber, and it is an int. And I want to display it in my label. And what do you display in your label? A string. So I need to convert from an int to a string because these types don't match. And you've done enough functional programming to say, I know what I need if I got to convert the type. I need map. You guys are awesome. And so what this says is, my int changed. I'm going to convert it by taking my int and asking for its description, and that gives me a string. And then assign says take that string and put it into my display labels text field. Isn't that reading kind of nice? So that's where target action has become. You go, but I liked my old one. It was simple. You'll get over it. So here's our target action pattern. And it is simpler, it's smaller code, but it's not extensible. Every time I do something, I have to do this. And here's what it looks like here. I'm saying display text, take this int, and convert it, and I'm doing all of that in my buttons action. Whereas in combine, my buttons action is so simple, and I do my conversion here when I map my publisher to my subscriber. Now, I got another app to show you. In this app, when I click the next button, I pick a random number between 0 and 2 and decide if it's rock, paper, scissors for you and the computer, and then we tell who won. Very impressive. Oh, the computer won. Tie. I didn't think I was ever going to win. Okay. So let's see how that looks. I have two labels that change, one for rock, paper, scissors for me, one for rock, paper, scissors for the iPhone, and then I've got to do something that picks the color for the screen. And so let's see how combine works for this. And so I need outlets to my two labels, one for you, one for the computer. So I need publishers for those two values. Great. I need subscribers. Great. And I need to somehow, when I hit that next button, choose a random number between 0 and 2 for one and 0 and 2 for the other. So I have this helper function called rock, paper, scissors. Rock, paper, scissors says you rolled 0, 1, or 2, but it also says, I don't trust you. You might have done this wrong, and you might give me a number outside of this, so I'm going to guard against this. How many of you use guard like this? A lot of people use guard let, but never use guard without let. Guard without let is so powerful. And so here's guard without let. It says, make sure that my index is at least 0, and it's no bigger than 2, otherwise return Spock. If it's between 0 and 2, return rock, paper, scissors, depending on what its value is. And so now that I have that, I can connect my publishers to my subscribers to fill the label, because my button is giving me a number between 0 and 2. I use this function to convert it into a string, rock, paper, scissors, and then I assign it to the labels. So this is feeling comfortable to you now, right? You can start checking in code. And the only thing that's different is I'm mapping it using this. Now, I could have put the closure in place, but I like this way of doing it. It's called point free. If you just list the name of the function, it says map using rock, paper, scissors, which I just love. So now let's color the screen depending on who wins. So you give me a 0, 1, or 2 and a 0, 1, or 2. You give me two ints, and I have to decide who won, and I'm going to give you back a UI color. So if we're tied, if first equals second, it's light gray. There's two ways you can win. You can either be one bigger than the thing before you in the ray, so rock, paper, scissors, paper beats rock, scissors beats paper, but also rock beats scissors, so we have to wrap around. So that's why there's two ways of getting green. Otherwise, I return red. So I have another subscriber. And now I'm going to tie that subscriber to a publisher, but I need to combine two values. How do I combine two values? I use zip. Do you guys use zip with arrays? Zip takes two collections and it zips them together. And so this says, look at your publishers, look at your value, look at the computer's value, and give me a tuple. The first thing is your value, the second thing is the computer's value, and that's wonderful because now I can dump that into the function because the winner function takes two inputs. So I can take zip and map it into the winner. You're not going to walk away being able to write this code. The point is just to build some intuition, to see how these things work. Well, maybe you'll walk away being able to write the code, but I sure couldn't. And now you'll assign it to the background color for the view. And so, okay, it is kind of a stupid example, but we can do validation, although I'm going to have a stupid example of validation. And in my validation example, if you're odd, you're not valid. If you're even, you are valid. And so what that looks like here is I have an outlet for my label. I have a published value for my int, and I'm just going to see, is it odd or even? So I start with my background color red, and here's how I connect my subscriber to my publisher. I take that number between 0 and 9, and I say, are you even or are you odd? So this is what I'm displaying the number. So that's just displaying the number. Now let's set the color. Are you successful or not? This is my validation. I look at the value, and I say, are you even, are you odd? How do you take an array and just pull out the even numbers? Filter. Look at you. You know everything. All these natural things from arrays are mapping across to combine. And there's a natural way to think of that. And so filter, I'm going to filter out just the even ones. And if you're even, then I'm going to go ahead and change the background color to green. If you're odd, I'm going to leave it as red because I reset it to red each time. Now, I don't like this code so much because I don't like resetting it to red somewhere, but I did want to show you filter, so I did it this way to show you filter. What I would do is take the setting it to red out of my next, and my subscriber would take my value, and I would map it, and I would say, if the number is a multiple of 2, return green, otherwise return red, and assign that to the background color. Again, if this is brand new to you, it may be hard to read, but as I read it aloud, does it kind of make sense to you? I'm describing this process. I find it very communicative. It's what I would tell you I want to do in this case, and you see it right there in the code. Now, I used to have a methodology called hate-driven development. And hate-driven development says I look at code that I hate and I get rid of it, and I really hate that I created a value subscriber for you, for the computer, and a win subscriber, and then I set them somehow. Can't I do it without those variables? Can't I just get rid of those? And the answer is initially no. If there's nothing to hold on to it, it's just going to go away. You've got to hold on to the subscriber, or the publisher says no one's listening to me anymore. And if no one's listening to me anymore, I'm going to stop sending the message out. So people keep saying there is no dispose bag in combine. So I've called this dispose bag. And it's an array of subscribers. And so what I've done here is I've said, look, dispose bag, put this first subscription in it. Dispose bag, put that second subscription in it. dispose bag, so the dispose bag is hanging on to all those, and as long as dispose bag is still valid, all of these will stay around. Or if you'd rather, we can do it with a dictionary. And if we do it with a dictionary, you can have, you can have key value pairs that describe it. You can say, here's my dispose bag for you, here's my dispose bag for the computer, and here's my dispose bag for the winner. And so you can remove any one of those that you want out of there as well. So I hope we've developed some intuition, but let's just check. You guys were yelling out map and filter at the right moments, and it means that you're used to this, taking an array and saying, look, if the number is even, I'll return green, otherwise I'll return red. And so if you look at 1, 7, 8, 5, if you look at that, the odd numbers become red. And the even numbers become green, and so this array becomes this array. And you say, well, I've got that. Well, good. If you've got that, then how do we do it in combine? What changes in combine is we're getting these numbers one at a time. So 1 maps to red. 7 maps to red. 8 maps to green. And so this intuition you've built up for arrays and collections is still true for things that you get one at a time. The difference is arrays are indexed over space. I've got my 0th entry, my 1st entry, my 2nd, where these are kind of indexed over time. This is the first thing that I got, my second thing that I got, and once you get that in your head, that's kind of the idea of combine. We have 3 pieces in combine. We have a publisher, so that was this dot value. My publisher is saying, here's something that you might be interested. I'm sending it out. And my subscriber says, I am interested in it. I want to do something with that thing. And in between a publisher and a subscriber is an operator. And an operator says, you're giving me an int, and I want a string, so I have to change it somehow. And we saw map, and we saw filter, and we saw zip. We saw a couple different things. And what's kind of cool about this is assign is not subscribed to value. Map is subscribed to value. Assign is subscribed to map. So the operator is both a publisher and a subscriber. It subscribes to the guy upstream, and it publishes to the guy downstream. And so assign is subscribing to map. Map is subscribing to value. And that, my friends, is a feel for combine. Obrigado.